Good afternoon. Welcome to the IoT track. And we have several speakers today. And we're going to be starting off with a talk entitled Addressing the Masses, Conversational AI and IoT. And Vijay Gurbani will be speaking from Vail Systems.
All right. Thank you, guys. Thanks for being here after lunch. I had a 1/3 probability of attracting you, so I think it worked out in my favor. So what I will present to you today is some of the work that we are doing right now in trying to bring about conversational interfaces using natural language processing to IoT devices. Just a little bit before I get started in my talk about the history of the company. So Vail Systems has been around since 1991, and it's actually composed of 3 companies. The main company is Vail, and then 2 holding companies called Versailles and Prosodica. Versailles is a services company that was formed in 2002, and Prosodica is a speech analytics company. So the interesting thing about Vail, from my perspective, my research area is multimedia networks, multimedia protocols, and security in these networks and protocols. But to me, once you turn a speech into an RTP packet, then I couldn't care less. You're right. I'm just going to route that RTP packet. I'm going to have SIP signaling that's going to direct the RTP packet. So I couldn't care less what happens then. So what I'm finding now is that at Vail, I need to worry about how that RTP packet got generated in the first place. Right? How are we going to talk? What utterances are? What type of information that we can extract from conversations? So to me, it's been very interesting from that perspective. So for those of you that don't know Vail, think of it in terms of anywhere from 8 to 10% of the call center business in the United States passes through our servers, which means that we have RTP, we have the media stream, and we have the signaling stream. And we have customer profile that we can build up, or we have customer profile that we can get by partnering with our institutions that use our software. So we can build all kinds of interesting models. We can actually build models that will predict when a customer calls into a call center whether the customer is in a happy mood or a sad mood or a neutral mood without necessarily analyzing the media itself. We don't look at the words that are being spoken. We just try to extract the essence of the conversation. So as you can imagine, in computer science, there's this effort known as affective computing, which kind of tries to push computers towards simulating human effects. A good example of that is today, if you call into a call center, and let's say you're having a great day, and you're in a very happy mood, and you call into the call center, and the call center presents to you a chatbot. So you will call in and say, "Hey, how are you?" And the chatbot goes, "I'm fine. How can I help you?" Right? So clearly, it's not reflecting your mood. If you talk to a person and you're exuberant, then the person would respond back in a similar manner. So one of the things we are trying to do is to try to see if we can use this natural language processing, these deep neural networks, to affect that kind of communication. So that's essentially one of the things that we're doing at Vail. I do so in my responsibility at the company as a chief data scientist. I'm leading the effort to coordinate all the AI and ML type of activities across the company. And as part of that, we do a lot of fraud detection, because we have lots of transcripts that we can get, and we can mine data from the transcripts and try to predict, who is calling to hoist a fraud, for instance. So I don't have too many slides. Instead, what I'm going to give you is some of my thoughts in being in networking, especially multimedia communications. Henning this morning gave a great talk. For those of you that didn't listen in, make sure you do catch it on the webcast. But the whole idea about networking research being in its middle years right now, So I've had the good fortune of working with Henning and being part of the SIP evolution as the protocol was being formed back in the IETF. At that time, I was working at Vail Laboratories, Lucent Technologies, and I kind of left after 21 years, and I'm now working with Vail Technologies. But one of the interesting things to me from a network protocol perspective is this fact that protocols are becoming more anthropomorphic. If you take a look at SIP, you will see it has invites, it has buys, it has cancels. Even if you do not know what it's trying to do, you can guess what it's trying to do. Invite is trying to set up a call or a session, and buy is trying to tear it down. So as these protocols become more anthropomorphic, essentially what we want to do as we move up the chain is we want to talk to our devices. And Siri and Echo and all these other ilk that you see have made it more commonplace for us to talk to our devices. So communication, speech, is an important aspect that we try to work in at Vail and try to see how we can do this entire area of effective communication. How can we replicate the emotions that are being displayed by a user calling in? So in that vein, so here are some more slides about the company, but let me try to motivate the problem that we are trying to solve here. So think about sensors, smart sensors. Every building, or most buildings, have these sensors embedded in the fabric of the building. These sensors might be temperature sensors, these sensors might be sump pump sensors, or just sensors in the room to see if anybody's in there. So one of the things that's interesting now as IoT scales up is that what's going to happen is that these building managers who are responsible for the upkeep of this building are not sitting down at their computers just looking at the data that's coming in back from the sensors. They're probably walking around the buildings. They're maybe going to Menards or going to Home Depot to get something, but they're mobile. But remember that the thing that they have in their possession is the cell phone. So what happens now if we try to take a conversational interface and bring that to an IoT device? So instead of now sitting down and passively receiving information coming from an IoT device, the building manager can actively query the IoT device and see what's going on. And not only can it query that, but it can query it in natural language. So it's not the case that it's going to call in and the interface is going to say press 1 to find out the temperature in the kitchen, press 2 to find out the temperature in the living room. I can just ask it questions, just like I would be talking to a colleague, or I would be talking to somebody who's answering me back in natural language. So the demo that I'll show to you in a couple minutes is going to be that type of interaction. We created, using natural language processing, a chatbot in a sense. And this chatbot essentially is the face of the IoT device that we are trying to portray and communicate with. And I'm just going to call in using a phone number, and it's going to have a conversation with me. So as you can imagine, there is many parts to this. There's obviously the natural language grammar. There's the natural language understanding. So to give you an idea about the moving parts, remember, I'm talking, so this media stream is now going to a model that's going to extract the entities from what I'm talking about, extract the relationships, and then it's going to fit these entities and relationship to a model. That model is going to do something, and it's going to generate back a response. The response is generated back as text, and then we have a text-to-speech engine which will render it as a voice stream on the phone. So you'll notice a little bit of a delay, and because this is an artificial intelligent chatbot, it has its quirks and idiosyncrasies, but hopefully those will be kept to a minimum as I talk to it. So what I'll do now is show you the demonstration, and then I'll just open up, and if you have any questions, we can talk about those questions. But I want to keep the slideshow to a minimum and have a more interactive discussion. So again, I'm a building manager, or in this particular case, I'll show you me talking to my chatbot at home. but you can imagine a building manager calling in and trying to see what's going on in the home, all right, just using the phone and natural language processing. So because we are engineers and not so creative, we named our chatbot HAL. For those of you that are of a certain age, you know what HAL refers to. For those of you who are not, maybe you want to watch the movie 2001, The Space Odyssey.
You know that HAL is IBM.
Yeah. One letter away from IBM.
Hi, welcome to HAL Home Automation. What can I help you with?
What is the status of the house?
I didn't quite get that. Can you repeat that?
What is the status of the house?
All systems are normal. Nothing out of ordinary to report.
What about the sump pump?
All systems are normal. Nothing out of ordinary to report.
What about the sump pump?
The sump pump is operating normally. It is running every 6 hours.
When was the last discharge?
The last discharge was October 16, 2019 at 10:22.
Do you remember when we installed the pump?
I didn't quite get that. Can you repeat that?
Do you remember when we installed the pump?
The pump was installed on March 9, 2010 at 10:10.
What is the life expectancy?
Based on the usage of the pump, this particular brand should be good till March 9, 2020 at 10:10.
Can you please set up a calendar notice for me to look at it on March 10, 2020?
Done. Anything else?
What's the temperature around the house?
Current temperature in the living room is 69.21 degrees. Family room is 68 degrees. Kitchen is 68 degrees.
And the basement?
I don't have a temperature reading for basement.
Is there anybody in the house?
There is no one in the house right now. Would you like me to change the temperature?
Yes, please reduce the temperature in the house to 65 degrees.
Done. Anything else?
That's it. Goodbye. So now a couple of things. If I was to show you my calendar here, you will notice that it's set an event on March 10, 2020 to remind me of the sump pump. Second thing, because we have a programmable platform behind it, what will happen is when the temperature reaches 65 degrees, it's actually going to send me an SMS message. So now we can interact with the customer, or we can interact with the device in this particular case by doing other exogenous things. So when it comes back and sends me an SMS message, I can send it further instructions on what to do with the particular device. And all that can be then parsed automatically at our back-end system, extracted, and then the IoT device modified to act accordingly. So there was a few interesting things about this particular demo. So one was that it maintains state. When I was asking it about the sump pump, it knew that what I was talking about was a sump pump. So when I said, when was the last discharge, it kind of knew that the entity I'm referring to is a sump pump. Later on, when I moved to asking about the temperatures in the house, it gave me an idea of the temperature in the living room, in the kitchen, and in the bedroom. And then I told it, and the basement, and it knew I was talking about temperature, so it assumed that I'm talking about a sensor temperature in the basement, right? So it has some information, state information, that we keep around and leverage to our benefit as it processes. The other interesting thing is that unlike a normal directed IVR, where you have to start at a certain root node and then move down, I can call in again and start anywhere I want to. I can ask it, what's the temperature in the house, and then ask it about sump pump or any other IoT device that I'm interested in. So all of this processing is taking some time. As you noticed, there was about anywhere from a 3-second to 4-second delay between when I said something and when it responded back to me. And that delay is reflective of the fact that my voice is being taken, sampled, RTP packets created, sent out to the server. The server takes those RTP packets, creates a voice stream, runs it through our model. The model then extracts. So the server actually takes my RTP packets and creates text out of it. Then we feed this text to our model. From this text, we extract the entities and the relationships. And then we have logic that figures out what I'm trying to do. And that logic will then do what I'm supposed to do. And then it'll generate a text response. That text response comes back to the system. And the system uses the TTS, or text-to-speech, and generates back the response that you see. So there's a little bit of a delay right now, but again, using edge computing, maybe moving things closer to the source, we can reduce some of that delay. So that essentially is one way that we can create these conversational AI interfaces for IoT devices. Another example given this morning, excellent example, was talking to a parking meter. So today, when I go to a parking meter and I have to scan something, or I have to, put my car number and put my credit card number, go to a website and register my car that way. But there's nothing stopping us now. We have the technology, not in mass production, obviously, but we do have the technology to be able to have this parking meter take instructions from us in natural language, and have the parking meter then talk back to us, as any other sentient device, so to speak. So that's essentially what I wanted to show you, and I want to open up the floor to questions that you may have. But Joe, my colleague sitting at the back, he also has access to HAL running on our server. So if you want a closed loop demonstration, or if you want to talk to HAL, please get in touch with me or Joe, and we'd be very happy to have you interact with HAL. Being engineers, we did put in an Easter egg. If you were to tell HAL to close the pod bay door, HAL, it'll come out and give you the response that you expect. So that said, I don't have any more slides, but I'll open it up to questions, and I would rather have an interactive session on some of the effects of this technology. So consider when you go to United, for instance, and you talk to their IVR system, it'll typically ask you what's your name, and it'll ask you what's your birth date. It can recognize names and record them. It can recognize digits, for instance, and it'll tell you to say 1 for international travel or 2 for local travel, right? So that is a more streamlined grammar. There's no AI going on there. That's just a normal IVR tree. You start from a root, you get input, and you move down the tree. But here you have more of a conversational mode, right? In a sense, I'm going from the bottom up. I'm not going into the system, and the system is not telling me I have a sensor in the living room, I have a sensor in the basement, I have a sensor here or there. I'm asking it, what's going on? If there was anything going on, it would tell me, and I can hone into it. Otherwise, I can just have a conversation with it, and the conversation is very, very, as you saw, natural language-like, right? So something has to sit down there and parse it, get the intents, get the entities out of my sentences, run the models, fit the models, do what you're supposed to do. All of that is essentially what it's doing behind the scenes. Yeah. So the intents and entities that we are extracting out, we are doing using an open source project called RASA, R-A-S-A. But RASA is running in our platform. which is, in a sense, omni-channel, because you can imagine starting the conversation on a phone and then continuing it on instant messaging, for instance. So eventually, any input that goes to our system gets transformed to text, and the text is then presented to Rasa to extract the entities, extract the intents, and then logic is run on those intents and entities.